Okay, so continuing from the previous video, we were talking about 8289 bus arbitration and lock signals. So this device basically permits the processor to reside on the system bus. So basically, whatever bus related locking and allowing is there, this would be performed by 8289 bus arbiter. So addition of 8288 bus controller and 8289 bus arbiter frees a number of the 8086 pins for use to produce control signals that are needed to support multiple processors. So now 8288, when we studied, we spoke about how exactly the operations will take place, like IO read, IO write, or memory read, memory write, or how to enable the DEN or DT/R. Here we will talk about which processor will be having the control. So that is done by bus arbiter. So the first pin is bus priority lock is one of these signals, the control signals. It is input to the bus arbiter together with status signals S0 through S2. The output of 8289 bus arbitration signals are bus busy, common bus request, bus priority out, bus priority in, bus request, and bus clock. So these are the various output pins of the arbiter. So they correspond to the bus exchange signals of the multibus and are used to lock other processors of the system bus during the execution of an instruction by 8086. In this way, the processor can be assured of uninterrupted access to the common system resources such as global memory. So basically, when the 8086 is sharing, sometimes it might require access which should not be disturbed. So for that, arbiter can be used. So it has all these pins which basically help the 8086 to have uninterrupted access. Now, Q status signals. Two new signals that are produced by the 8086 in the maximum mode system are Q status outputs QS0 and QS1. Together, they form a 2-bit Q status code QS1, QS0. So, what does it do is, let's see. So, if both are 0, there is no operation. If it is 0, 1, the first byte, the byte taken from the queue was the first byte of the instruction. If it is 1, 0, the queue is empty. And if it is 1, 1, the next byte, the subsequent byte was taken. So, this is the queue status code. Next is the local bus control signal, which is request and grant signals. In a maximum mode configuration, the minimum mode hold HLDA interface is also changed. So this changes to this pins. These two are replaced by request slash grant lines, RQ slash GT0 and RQ slash GT1. They provide a prioritized bus access mechanism for accessing the local bus. So, well, this is all about maximum mode interface. So, it's a little confusing if we do it step by step. Let me give you an overview now so that you understand better. Now, let us look at this diagram. 8086 microprocessor is there. The three status pins are connected to bus arbiter as well as bus controller. Now, let us first talk about bus controller. So the input which is coming from 8086 to bus controller is only S0, S1 and S2. And we have already studied what is the function of S0 to S2. So basically it will give 8 different commands from the microprocessor to the bus controller, which includes memory read, memory write, IO write, ILTA bar, etc. So all these things are indirectly still controlled by microprocessor with the help of bus controller. Other than this 8 output pins, we also have 3 control signals which are DEN, DT/R bar and ALE. These are entirely controlled by the bus controller. So basically all the pins in the 8086 are now free to be used for something else in the maximum mode. So all these pins are dedicated to 8288 now. Basically, this is all about 8288 bus controller. It is going to control the address in the data bus, uh, and it will relinquish 8086 from this controls. Now, if we talk about the bus arbiter, so sometimes it might happen that the 8086 will require uninterrupted access to the global resources. We have already discussed global resources are nothing but the common resources which can be used by any of the co-processors. So if sometimes 8086 wants uninterrupted access, we make use of 8289 bus arbiter. So the bus arbiter has various pins like busy, uh, bus request, bus clock, bus priority, etc. So now, depending on how much time the microprocessor requires uninterrupted access, these pins would be used. In short, in brief, if we can conclude about 8289 bus arbiter, we can say that it is used to lock the common resources dedicatedly for the 8086 microprocessor. Now, the last part they are talking about is about the old and the HLDA pins of minimum mode are now replaced by RQ slash GT0 and RQ slash GT1 pins. So they are nothing but request and grant pins. They work very similar to the hold and HLDA, but they also have priority unlike hold and HLDA. Hold does not have priority. Any peripheral which first gets access to it is going to use it. However, request slash GT do have two priorities, RQ slash GT1, which is having a higher priority as compared to RQ slash GT0. And since they are bidirectional pins, they can perform a single pin can perform both the tasks, hold as well as HLD. So that is in all conclusion of maximum mode interface. So that's it for today. In the next lecture, we will do 8086 minimum mode system and 8086 maximum mode system. So it is just a revision of what we have done in the interface, and then we can move on to the timing diagram. So that's it for today. Thank you. Take care.